A common thing that we're asked to do is to find the equation of a parabola knowing what its graph looks like or having some information about its graph. So that's the focus of what we're looking at here. So the number one thing we have to identify is what form are we going to write the equation in. So in this case that's going to be vertex form. So I'm going to write that down for myself right away. I've got y equals a times x minus h squared plus k. So I have to know what my target format for the equation is. And so I look at this and I see that there are three things that I need to know. I need to know what the value of a is, and then I need to know what h and k are. Now hopefully we remember from our study of vertex form is that hk are the coordinates of the vertex. And so we're fortunate in this problem that we're told that this parabola travels through the point -8, -9, which isn't useful to us immediately, though we'll make use of this in just a second. But as far as the vertex is concerned, we're told what the vertex is. It's -5, 9. So I'm going to move to right away plug that in for h and for k. So my h value in this case is -5, my k is 9. So I'm going to slot those things into my equation right away. So I've got y equals, I still don't know what a is, I'll deal with that in just a second, and then x minus this -5, but when I go minus -5 it's going to become x plus 5 squared, and then plus k, well my k value is 9, so that's going to show up as I see it. So I'm 2/3 of the way there. I've got the h and k plugged in, but I still need to figure out what the value of this a is right here. And so that's where this additional point is going to come in. Because if I know that that point works in my parabola, if I can, and I can see it on my graph, -8, -9, if I go to this location right here, I can see that my graph is going through that location. They're not lying to me. But if I know that that point is on the curve of my parabola, then I know it's going to work in my equation. So I'm going to make use of that by plugging in those coordinates for x and for y, and then the only thing that will be left for me is, as a variable to solve for, will be a. So I just have to be careful about the order. In place of y, I'm going to put -9, because that's the y coordinate, equals a, which I don't know, that's what I'm going to be solving for, times -8 in place of x, and then I've got the other pieces, the +5 and the +9, that I was able to plug in as a result of knowing the vertex. And so now I've just got to solve for a in this equation. And then I'll know what my vertex is, I'll know what my dilation factor is, and so then I'll be able to finish off writing my complete equation. So I've got -9 equals a times, now -8 plus 5 is -3 squared plus 9. So if I square that, staying with my order of operations here, I've got -3 times -3 is +9. So I have 9a plus 9. So I need to isolate that 9a, so I'm going to subtract 9 from both sides. So now I've got, if I move to the side here, 9a equals -9 minus 9 doesn't equal 0. It's -18, because I'm going deeper into negative territory. And so now finally I'm going to just divide both sides by 9, and I'm going to get a is equal to -2. Now that looks about right to me as I look at this parabola. It's opening down, first of all, so I know that a has to be negative, and I can see that it's a bit steeper than the regular kind of basic parabola. It's a pretty narrow parabola here, so having a number like 2 as the dilation factor seems about right. But with that, I'm going to go ahead and write my equation. So I've got y equals, so in place of a, I'm going to put -2. Then I've got x plus 5, since we use the 5 as the x coordinate of the vertex, and then plus 9 as that y coordinate of the vertex. And so there's the equation for this parabola. In our second example, we're this time asked to write the equation of our parabola in intercept form. So just like we did on the previous example, where we right away wrote down what vertex form looked like, I'm going to do the same thing here, but this time for intercept form. So again, from our previous study, hopefully we remember that that's a times x minus p and times x minus q, where p and q are x intercepts. Whoops, let's actually try to write intercepts there. There we go. So I've got the information given to me about the intercepts. So I've got these two numbers right here. So one of those is going to be p, one of those is going to be q. Doesn't matter which one is which, but I'm still going to have to figure out what a is, but at least I can get this far. So it's somewhat similar to what we saw with the vertex form in the previous example. So I'm going to have a times, and then it's x minus negative 2. So again, minus a negative means it's going to become x plus 2. And then x minus 8 is just going to stay x minus 8. So I've plugged in the two x-intercepts that we were given. And so now again, I still have to figure out what this value of a right here is. And just like we did on the previous example, I'm going to use this additional information about the parabola, where they tell me that the parabola passes through this location. So if I know my parabola goes through that point, I know that if I plug that in for x and y, it's going to work in my equation. So once again, just cautious to plug in the correct number in the right spot in the equation. I'm going to plug in 8 in place of y. A is what I'm going to be solving for. And then in both places, in place of x, I'm going to put that negative 4. So I've got negative 4 plus 2. I've got negative 4 minus 8. So very similar. I've got some arithmetic to do, so I still have this a out front. We've got negative 4 plus 2 is negative 2. Then I've got negative 4 minus 8, so negative 4 plus negative 8 gives me negative 12. So I'm going to keep going with my arithmetic here. I've got negative 2 times negative 12 is 24, positive 24. So I've got 24a over here on this side. And then finally, to solve for a, I'm going to divide both sides by 24. And so if I do that, just be careful, our answer is not 3. We have a fraction over there. It's 8 divided by 24. So we just need to reduce that fraction. And so hopefully we can find that it reduces to 1/3. So now, armed with this information here, to go along with what we already plugged into our equation for the two x-intercepts, p and q, we can write our equation. So we can go y equals, in place of a, I'm going to put 1/3, and then we've got the rest of it, x plus 2 times x minus 8. And once more, just like we did on the last one, it's not a bad idea to consider, does this 1/3 make sense for us for what we see in front of us? Number one, it should be positive because our parabola is opening upwards. And then this one's a little bit wider than our standard parabola. We can see it's going up a little bit more slowly on both sides. It's going wider than our standard. So that fraction value for a of 1/3 seems like it fits the graph that we see in front of us.